Okay, now, the next part of this problem is to show that this function is differentiable at negative 10. So we already showed that it's continuous if we have c equals 10b minus 5. So now, showing that it's differentiable at 5, or excuse me, at negative 10, involves doing this limit. So we're going to show the limit of the difference quotient, right? So we're, oops, yeah. The limit as x approaches negative 10 from the left okay? So we're going to find that this, we're going to show that this limit exists. And so we're going to use f of x minus f of negative 10 over x minus negative 10, which is x plus 10. And so now, since we're going from the left, we're going to use the top one. So this is going to be the limit as x approaches negative 10 from the left of 1/10 x squared plus bx plus c minus f of x at negative 10, right? Which f of x at negative 10 is equal to 5, right? That's what we showed that we could do it. So minus f of the negative 10, which is going to be 5. And then we're going to have x plus 10, right? So that's what we have so far. Okay? So now, now what we're going to do is we're going to substitute in for c. Right? So now we're going to substitute for c. And so this becomes the limit as x approaches negative 10 from the left. And this is going to be 1/10 x squared plus bx plus, and c, where's c? So c is going to be what? 10b minus 5. 10b minus 5, and then of course minus 5. I'll put it up here. So minus 5, and then we have x plus 10. Okay, now let's simplify this. Okay? So what I'm going to do is to simplify this because I don't want this fraction here. It'll make it easier to deal with. So let's get rid of the fractions, well, the one fraction anyway, and multiply the top and the bottom by 10. So if we multiply the top and the bottom by 10, then our limit becomes this. X squared plus 10bx plus 100b and then minus 100 over 10 times x plus 10. Okay, now we can factor the top, and the factor is going to be, one of the factors will be x plus 10. And so we're going to get x plus 10 and then we get x minus 10 plus 10b. Over 10 times x plus 10. So that's why I didn't expand it out here, because again, I want to get rid of that x plus 10 in the bottom. And so now, those cancel, and we get the limit as x approaches negative 10 from the left of x minus 10 plus 10b over 10. Okay. Now, now we just take the limit. So if we put in negative 10, we get, hold on a second, negative 10. Is that right? Yeah, I believe. So negative 10, so that gives us 20 plus 10b, which is going to give us 2 plus b. Is that right? Oh, I'm sorry. Minus. So minus 20. So yeah. So then, of course, this would be, we could write this as b minus 2. Okay. So, we're done. By the way, how we got from here to here is you could do factor by grouping. You could group these two and group these two and do factor by grouping, and you'll get this result, just so you know. And that's usually when you have 4 terms, that's one of the first things you want to try. Okay, now we're going to do the right side. Okay, so now let's do the right side and see what we get. Okay, so now let's do the right side. So we're going to do the limit as x approaches negative 10 from the right, which means we're going to use this one. So again, it's going to be f of x minus f of negative 10 over x plus 5. No, not x plus 5. X plus 10. And so this is going to equal the limit as x approaches negative 10 from the right. And now, obviously, this is going to end up being negative 1/4 x plus 5 halves minus 5 over x plus 10, right? And now it's time to factor okay, so because we have fractions here, let's multiply the top and the bottom by 4 to get rid of all of them. So that means we're going to end up with the limit as x approaches negative 10. This is going to become negative x. Yeah, negative x plus 10 minus 20. And then this is going to be 4 times x plus 10. And then we can factor the top, which is going to give us the limit as x approaches negative 10 from the right. We're going to factor out a negative, and that's going to give us what? This is going to be positive minus positive, so it's going to be, what is 4 times, what, 2 numbers? Okay, so let me look at this way. So x minus, oh, hold on. Oh, hold on. I don't need to factor this, hold on. This is going to be x, oh, this is going to be x plus 10. Okay, yeah. And then 4 times x plus 10. Okay, so easier than I thought. I thought there was an x here. For some reason I thought it was quadratic. Okay, so now this is going to cancel and we get negative 1/4. So now we have to rectify the two sides, because the two sides, the limits have to be the same. So that means that b minus 2 has to equal negative 1/4. And guess what? Now things are going to unfold, because now we can solve for b. So b is going to end up being equal to what? 1 3/4. Or 7/4. Now, we know what C needs to be. So B has to be 7/4. And C has to equal 10 times B, which is 7/4, minus 5, which then equals what? It's going to give me so minus 5, so that'll be what? 10 halves. And so that's going to be 25 halves. All right, or 12 and a half, right? So we found B and C that will now satisfy this, which means it's going to be continuous and differentiable. So those are the two values. So B has to be 7/4 and C has to be 25 halves in order for this function to be both continuous and differentiable at negative 10. And we're done. Have a great day.